You hand Runway Gen for a prompt that describes a mountain lake at dawn. You type, slow push in towards the cabin on the far shore. And instead of a chaotic, AI-generated glide that drifts off target, the camera moves exactly where you told it to go. You set the start frame, you set the end frame, and the camera executes that move with the precision of a slider on a physical rig. By the end of this episode, you will know how to lock a camera move to specific frames in your footage, so you can fake a dolly shot or a crane move without touching a real camera. This is for anyone who has ever needed a camera move that simply wasn't in the original plate. You shot a static wide shot of an empty street, and now you need a smooth pan to reveal a character walking into frame. You cannot reshoot. You are a solo filmmaker, a video editor, or a motion designer who needs to add life to B-roll without hiring a camera operator. It removes the problem of reshooting or compromising with a cheap digital zoom that looks like a phone recording. This feature lets you treat AI as a post-production camera rig. It removes the fear of asking for camera moves and getting warp-fest instead of a clean glide. If you have ever wasted hours keyframing scale and position in your editor to fake a push-in and it still looked flat, this is for you. It is for the creator who understands that the move is the story, but who never had the budget to shoot it properly. Open Runway and start with a new Gen 4 generation. Do not use the image-to-video workflow for this. Start from a text prompt. The reason is simple. Text-to-video gives the model full freedom to render the entire scene, and that freedom extends to the virtual camera. You will lose some of that freedom if you feed it a still image, because it spends its energy trying to preserve the exact pixels of that image. For camera control, you want the model working on the motion, not just the likeness. So type a clear scene description. Keep it simple. A single red car parked in a concrete garage, fluorescent lighting, shot on 35mm. Avoid clutter. The model needs to understand the space it is building. Now, the critical part. Add the camera move to the end of your prompt. You type, camera pushes in slowly towards the driver's side door, ending on a close-up of the side mirror. That is your start and end frame. You do not get to click and drag a path on a timeline. You describe it. This is where precision lies. Be specific about the subject of the end frame. Say, ending on the license plate, or ending on the front wheel. The more concrete the destination, the more confident the move. The model plans its entire trajectory based on that final framing. If you say, push in, without a destination, it will push in on whatever is interesting at the center, which is a coin flip. So, spend 10 seconds writing the end frame. That is why the move works. Set your duration. Gen-4 lets you generate up to 10 seconds of video. Choose 10 seconds. A push-in needs time to breathe. A 5-second move feels rushed and digital. 10 seconds gives the motion a natural ease in and ease out. The model uses those extra frames to calculate a steadier path. Shorter clips amplify any jitter in the algorithm because there is less time to distribute the motion. So go long. 10 seconds is your friend. Generate the clip. Watch the first pass. 9 times out of 10, the move is clean, but the speed is off. That is fine. You fix it in the edit. Take that 10-second clip into your editing software. In Premiere Pro or DaVinci Resolve, add stabilization again if you see micro jitters, but usually you will not need it. Instead, you will want to retime the move. The AI gives you a constant velocity push-in, which feels robotic. Real camera moves accelerate and decelerate. So, speed ramp the clip. In the first 2 seconds, hold the shot almost static. Then, ramp up the speed from frame 2 to frame 7. Then, slow it back down for the last 2 seconds. This is how you get that professional, weighted feel. The AI gives you the geometry of the move. You give it the physics. Now the why. The reason you specify start and end frames in text is that Runway's model uses a diffusion process that is directionally aware. It simulates a camera rig in 3D space. When you tell it where to end, it backsolves the path. It does not just move pixels. It moves perspective. You will see parallax. The foreground slides past the background at a different rate. That is the sign of real camera motion. If you see the whole frame scaling uniformly, that is a digital zoom. That is a failure. Regenerate with different wording. Ask for a focus pull towards or dolly instead of push in. These slight prompts do shift the physical simulation. I tested this on a 1-minute product showcase for a local furniture brand. The job required a precision pan over a walnut dining table, starting at the left edge and ending on the center fruit bowl. Running Gen-4 with the prompt. Camera pans left to right over a walnut table, ending centered on a ceramic fruit bowl. 10-second generation took 40 seconds. Output was a 4K, 30 frames per second file at roughly 60 megabytes. I generated it 5 times to compare the pan paths. 4 out of 5 clips were rock solid. One had a subtle drift where the camera crept forward during the pan, losing the framing. I picked the best one. Delivery time was 12 minutes, including generation and a quick color pass. The client thought I shot it on a gimbal. The file size was 60 megabytes, which is perfectly manageable for a direct upload. Total cost for those 5 generations was under 2 credits, which on the standard plan is less than $1. The limits are real. You cannot control the camera move on a frame-by-frame basis. You describe the start and end, but the intermediate path is the model's choice. If you need a specific arc or a sweeping crane over a subject, Gen-4 will either flatten it or get it wrong. Another limit is motion blur. The model renders sharp at every frame. Real cameras have rolling shutter and blur on fast moves. If your pan is too aggressive, it looks like a video game screenshot slideshow. You will need to add motion blur in post with a plugin like RealSmart, and that adds time. Do not use this for precise match moving. If you need to composite a 3D object into a live-action plate, the AI-generated camera does not export a usable tracking data file. You will have to manually track the footage, and the soft AI shadows will fight your tracker. Finally, the longer the move, the greater the risk of subject morphing. On a 10-second push-in, faces and text can warp subtly. It is noticeable on close-ups. So do not use this for a 10-second extreme close-up on a person's face. The model will start to melt them halfway through. The obvious alternative is to do it in After Effects with a still image. You import a 4K still, animate the scale and position over 10 seconds, and add a camera layer with a slight focal length shift. That gives you total control over the path. It also costs 0 credits, but it is a 2.5D trick. You get the zoom, but you never get real parallax. The furniture piece I just tested would have looked flat with that method because the objects are stacked in depth. The AI method gives you actual spatial separation. The After Effects method wins in one specific situation. If your scene is a flat graphic, a poster, a map, or a UI design, use After Effects. Those have no physical depth, so the AI has no geometry to exploit, and you save the credits. So, today, open Runway and type a prompt for a simple scene with one clear subject that you want to push in on. Describe the exact end frame, generate 10 seconds, and then speed ramp it in your editor. See if that feel of a weighted, physical move changes your shot. Text prompts for style transfer, applying a new look, like film, 3D, or anime, to your video. That is next.